Good day. Good day. We are carrying on with will it precipitate form. What does that mean? Well, we did one video, the PowerPoint, where we just outlined the rough steps. The second video gave more detailed steps and did one example, question 1. And in this video, we're going to do number 2 and number 3. So we have a volume and concentration. We're told what the precipitate is. And we say, okay, how do we attack this? Well, we have our magnesium nitrate. We're going to dissociate it. We're going to take its volume and concentration, multiply, and we get our moles. Remember, this should have been in liters. That's why we get a tiny number. Now, we have a 1-to-1 ratio. So we get that number of moles of magnesium, and we don't care about the nitrate, just happen to do that. We repeat for the potassium carbonate. So potassium carbonate dissociates like so, volume and concentration, get our moles, and we end up with a 1-to-1 deal. Don't care about the potassium. Well, those are moles, that's all great, but we have to get concentration of magnesium and carbonate ions. So that means we take our 40 mils and 60 and add them together. Total volume is 100.0 mils, so it's 0.1000 liters. That's what we're going to divide by. Makes for lovely easy math. And now we have our concentration of magnesium ions and carbonate ions. That's the hard work. Be organized, spread it out. Here is the dissociation equilibrium for our precipitate or possible precipitate. So we write out our KSP expression, but we call it tip in this case. We know it's the magnesium times the carbonate. The 0.032 comes here, the 0.0060 comes here. Multiply it out and we get a tip of 1.9 times 10 to minus 5. Back in the question, it told us we have a KSP of 2.6 times 10 to minus 5. So our last step is to compare these numbers. KSP there, tip is there. The tip is less than KSP, so we don't make a precipitate. We were close, but we came up short. We're going to do the same thing for number 3. And again, often you're not told what the precipitate is. But since we have silver nitrate, we go, well, nitrate never precipitates, so it's got to be the silver and the chromate, and that's why we have silver chromate with the proper formula. We're going to dissociate the silver nitrate to get the silver concentration, and we're going to dissociate chromate or sodium chromate to get the chromate concentration. So there we go. We dissociate this. We have our volume and concentration. Remember, that's in liters, so we get this tiny number of moles. This is in red because this is what we care about, the silver moles. We do the same thing for the sodium chromate. Boom, boom, bim, bam, bomb. And we go and we have a 1-to-1 deal. So we have 1.5 times 10 minus 4. 25 and 75 is 100. So we have 100 milliliters, 0.1 liters. That's what we're going to divide by. So we now have our concentration of silver ions and we have our concentration of chromate ions. Again, that's the nitty-gritty, that's the hard work. Now we're into the easy stuff. Here's our dissociation of the silver chromate. 2 silver ions for every chromate, and we got to remember that 2 comes in here and there's a chromate. Now the 0.0010 comes in here and we're going to square it, and the 0.0015 comes in here. We multiply it together, we get 1.5 times 10 to minus 9. Our KSP from the question was 9.0 times 10 to minus 12. Tip is bigger than KSP, so therefore precipitate forms. If you follow the recipe, these questions are fairly straightforward. They're fairly obvious questions because usually it says, will you get a precipitate?